I'm a senior consultant here at Webstep, and I get to talk about Neptune today. The kind of reason I wanted to talk about this was a quip made by Corey Quinn that Amazon still had not really explained what Neptune was and why in the world you would need Neptune. And that's kind of understandable. Neptune is in this very, very small intersection. Plenty of people know about AWS. Plenty of people know about databases. Not so many people know about graphs. Even fewer work with graph databases, and fewer still work with Neptune. So I'm going to try to give an intro to Neptune and perhaps even be able to explain why you would want to use it, or possibly why you don't need to use Neptune. I think that's an interesting question as well. Graph databases are not for everyone. So I'm going to just give a super quick intro to what graphs really are. And then we're going to start looking at Neptune from the console and talk about graphs more in depth and look at actually working with graphs in Neptune. So graph is, of course, just a silly word for network. A network can be a lot of things. It can be a social network. It can be a computer network. It can be an electricity grid. These are all networks, or it can be represented as networks nonetheless. And representing networks theoretically, abstractly, tends to look something like this. You have these nodes, which is also called a vertex because we want to use strange words. And they're connected by arrows, which we call edges. These edges are drawn here with an arrow, which indicates it's a directed edge. It goes from A to C. A graph can also be an undirected graph, meaning there's no edge, there's no arrow. It's just goes either direction. The typical example here is Facebook is a non-directed graph in that if you're friends, it's a symmetric relationship. Twitter, on the other hand, is directed. You can follow someone, and they might not follow you on Twitter. We're gonna be focusing on directed graphs today, but I don't think that's going to be a major feature, really, of what we're looking at. But just know these are two of the types of distinctions. Managing Neptune is quite familiar if you're used to managing RDS. You have the database dashboard. You can view metrics just like you would in RDS. You have snapshots, and if you want to create a new cluster, new database, that will also look very, very familiar. There we go. The instance types are even RDS. There's production and there's development. The option, it's VPC only, just like RDS. The one new thing here is that you can configure a notebook while you're starting Neptune, and that notebook will be linked to your graph, to your graph database. And if you want to really work with Neptune in a more production-like environment, you can enable IAM so that you can authenticate with Neptune natively from, say, Lambda. I've already got 2 databases going. I don't need to create any more. But it's actually that simple, especially if you know RDS. Now let's start with let's get into this might be where confusion could ensue. Even though Neptune is a graph database, it's kind of 2 graph databases in one, and because there are 2 very, very different types of graphs. The one type of graph that people usually think about when they think about graphs or networks is the property graph, where you have a node. In this case, the nodes represent airports. The airport has some attributes. They're located in or close to a city. They have an airport code. They're in a country. They have other attributes as well. The edges represent, in this case, flights between airports. The flights have attributes themselves, for instance, the distance traveled. And this makes it possible to just traverse the graph and find, for instance, the number of ways to get from Austin to Wellington, which is kind of difficult to do without a graph, really. It gets really recursive, and graphs, these types of property graphs, are often made to optimize those types of traversals. The other type of graph, which is really less known, to put it mildly, is a knowledge graph. These are not meant to be traversed. They are, as the name hints at, they're meant to represent knowledge, which is a very abstract concept. In this little example, the knowledge is soccer. We've got 2 soccer teams. The nodes here, Chelsea and Manchester, don't actually have any attributes themselves. They have edges that represent properties in some way. The team has a team name. It has a home stadium. It has a nickname. And they're both playing in the same league. It might look very similar, but it's really very different at the same time. And we'll get into this. The query language is a very different one. It's not made to be traversed. And actually, I think it's better for me to just show this in a little bit. Because this is kind of a strange creature, I want to explain why someone might use it. There's a website called UBpedia that is basically a subset of Wikipedia, but structured so that you can query it online. Like here, we can find people born in Berlin before 1900. Of course, this is people on Wikipedia born in Berlin before 1900. But you can actually get this in a structured format by writing a query. And that's actually kind of cool. Amazon Alexa uses knowledge graphs as well, and Amazon is actually hiring knowledge engineers who can work with Sparkle to construct knowledge graphs for specific domains. So if you ask Alexa about football, I guess, Amazon might be able to tell you something about that. Alexa might be able to tell you something about that from a knowledge graph they're constructing. Similarly, Google uses knowledge graphs. These little sidebars you get sometimes, they're constructed from a knowledge graph. Even more interesting, Google Shopping, if you search for milk and Google knows where you are, you might get a list of grocery stores. Grocery stores are not milk, but Google knows that grocery stores tend to sell milk. It doesn't have to know anything in particular about which grocery stores sell milk, but they're representing the fact that grocery stores sell milk in a knowledge graph. So they're there. They're just far beneath the covers. So okay, that's it for, well, I have 2 more slides, I guess, but for now we're gonna skip the theory. I have spun up already some notebooks that I'm gonna show. The first thing that tends to be skipped is just how do you even get data into Neptune? If you've worked with constructing knowledge graphs before, this will be somewhat familiar. You populate a graph by loading nodes and edge lists. The node lists are just a list of what represents your node. Typically, they need a node ID, and whatever else you load is the attributes. In order for Neptune to load this, the node ID needs to be denoted by a tilde, this particular field, tilde ID. You can also have a label, which is also one of these reserved fields denoted by a tilde. And you have edge lists, which is much of the same thing. There we go. They have a from and a to denote the nodes, the node IDs that the edges go from and to, and whatever else is there is the node properties, the edge properties. And also here you can have a label. And yeah, loading this is can be done quite simply through this cell magic that Amazon has made, where you load this from an S3 bucket somewhere. You have a number of formats you can load this in. CSV is the most common format, I guess. All of these formats are for loading knowledge graphs. Up until very, very recently, this OpenCipher format was not here. So this was actually a surprise just the other day to find it. And you need a load ARN, which is basically the ARN for a role that has read access and that is attached to your database and can be assumed by SageMaker, because this notebook is really SageMaker. Having done this already, I'm not going to load anything more, but going to actually writing queries, we have for property graphs, the kind of built-in language is one called Gremlin, which is kind of a strange language. You can evoke this again with the macro here. The graph is represented as a G. The capital V is short for vertices. And so just selecting 5 vertices just gives you basically 5 JSONs with the properties. You can select edges as well here, and the edges are fairly thinly populated. Live coding is always a gamble, but it seems the notebook has decided to take its time now. This should be really quick. Moving on, in any case, we can write fairly complex queries. As you might have seen, the data here is public transit in Oslo. This is public data. And I've basically created a network of all the routes, which means I'm able to start traversing from a given stop. Here we see just traversing 3 times from a given stop. You can find different paths. You can find the path from one node to another if I want to get from Enola to Deaskog. This is actually the next stop, which is interesting because the graph is also really good at finding, well, scenic routes, really, if you really want to take your time. A somewhat longer trip, perhaps, if you want to get from Bogerud to Blindern. It will actually get you there, and I even double-checked the subway map. That this is correct. This particular graph doesn't really care about the lines themselves. That's for more complex. I am running late on time. I realize that. The Sparkle queries, the knowledge graphs, this really strange language here. I'm actually gonna really. This is exactly what I hoped was going to happen. Amazon has decided that I need to log in again. The Sparkle language is very, very strange. We saw a couple of queries already. But what we haven't seen yet is that most of the graph is basically just URIs. If you look at the content of a graph, it's almost illegible until you really, really start digging into it, because it really prioritizes uniquely identifying each node. And if you dig into it, you will find some explanations for the nodes. Amazon is not willing to play ball. But yeah, this language is really, it looks really complicated. You have, because the graph is just everything is a node. Instead of a property, you have to traverse out really, really far. Eventually, you'll find labels, you'll find dates, you'll find strings. But it really does look, the kind of barrier to entry there is non-trivial, to put it that way. It looks like we have time for questions.